Here we are taking the topic laws of motion, its basic concepts, important terms and formulae. Among that, the first one is the particle dynamics. It is the branch of mechanics in which we study the motion of particle. Not only the motion of particle, we also consider with reference to the cause of motion. And cause of motion is always the force. So in detail, we are talking about motion as well as the force that is responsible for that motion. Among that, the first law of motion that gives us the definition of force. Second law of motion that gives measure of force, and the third law of motion that tells force always exist in pairs. So these three laws are depicting the important properties of force. Then the second law of motion is the real law of motion. The inherent property of a material body is to remain at rest unless acted upon by the force is called inertia of rest. The property by virtue of which it tends to maintain its uniform motion is called inertia of motion. The property by the virtue of which body tends to maintain its direction of motion is called inertia of direction. Next is the total quantity of motion possessed by a moving body is called the momentum. Momentum is a vector quantity. It is denoted by small p. It is equal to the product of mass and velocity. M into V is the momentum of a body. Next is the force is product of mass and acceleration. The absolute units of force in CGS is dyne and SI unit is Newton. 1 Newton is equal to 10 power 5 dyne. When a large amount of force acts for a very short time, then we don't measure the force, rather we measure how much is the effect of force, and that effect of force is called the impulse. It is a product of force and time, the duration of time for which the force has been applied. It is a vector quantity. The next point is about impulse. It is the change in momentum of a body. Impulse is equal to the area under the force time graph. This direction we have taken the force, and in this direction time is being taken. Let this is a curve. Now in this curve we have taken, say, any strip for time t1 to t2. Now area under this strip, let it be a, b, c, d. So area of a, b, c, d. This is a force time graph. So this will be equal to the impulse for this time interval, and that time interval is t2 minus t1. So impulse that have been is equal to the area of this strip. The next is, if a man standing on a stationary lift, or if lift is moving with uniform velocity. See, in this case it is stationary. In the stationary there is no acceleration. If the lift is moving with uniform velocity, again the change in velocity is not there, so acceleration will be zero. Suppose this is a lift and this is a position of a body. The reaction is in upward direction and weight mg is in downward direction. For stationary, the a is 0, and for uniform velocity again a is 0. So in that case r will be equal to, the reaction on the body is equal to mg, and in other words the apparent weight is equal to the real weight of the body. Now if a lift is falling freely, then the man standing in lift experiences a condition called weightlessness. Here the lift, it is acceleration due to gravity. So the net force is equal to the reaction plus the weight mg, and in this case the reaction will be equal to mg minus f. So f is equal to m into a, but a here is acceleration due to gravity, as body is falling under the acceleration due to gravity. So this is mg minus mg, and this comes out to be reaction on the body is 0. It means it is a free fall, weightlessness condition is there. Now the 13th point, if the lift accelerates in upward direction with constant acceleration A, then the apparent weight of man standing in the lift is greater than the true weight by an amount ma. See here, the reaction is in upward direction and the force with of the weight is in downward direction mg. Since the lift is accelerating in upward direction with acceleration a, therefore the force in upward direction is given by F equal to R minus mg, and R is equal to ma plus mg. So here we can see that true weight is mg and acceleration is a. So plus ma is being added when the body is moving in the upward direction in the lift, and the acceleration will be acceleration acting on the body will be g plus a. Now the next condition is if the lift accelerates in the downward direction with acceleration a, then the apparent weight of the man standing in the lift is less than the true weight. Let us see how it is so. This is the reaction R and the weight mg is acting in the downward direction. The total lift is moving in the downward direction with an acceleration A. So the net force is equal to mg minus R, the reaction. So R is equal to mg minus F. Putting the value of F, mass into acceleration, we will get m is into g minus A. It means whenever it is moving in the downward direction, the apparent weight of the man is less than the true weight. The next is when two masses, say m1 and m2, are connected to the two ends of an extensible string passing over a smooth frictionless pulley, then the acceleration of masses is given by m1 minus m2 divided by m1 plus m2 into g, and the tension in the string T is given by 2 m1 m2 divided by m1 plus m2 into g. According to the law of conservation of momentum, the total momentum of a system remains constant in absence of external force. Next is the law of conservation of momentum is derivable from both Newton's second law of motion as well as Newton's third law of motion. The next point is about the rocket. The net force acting on rocket is equal to the difference between the thrust and the weight of the rocket. The velocity of rocket at any time is given by V is equal to V naught plus VR log to the base E m naught upon m minus gt, where V naught is the initial speed, m naught is the initial mass, and VR is the relative velocity of the gases, and m is the mass at any time, say t. Next point is the burnout speed of the rocket is given by Vb. It is equal to V naught plus VR. V naught is the initial speed, VR is the relative velocity of the gases, log to the base E m naught upon me, where me is the mass of the empty container. If the lines of action of force intersect at a common point, then the forces are said to be concurrent. Next is about the concurrent forces. They are said to be in equilibrium if there is no change in the state of rest or of uniform motion of a body on which the concurrent forces are acting on. Next is about the equilibrium. It is of two types. One is the translation equilibrium, another is the rotational equilibrium. As the word it is indicating, translation equilibrium is the one in which the vector sum of forces, this is we are talking about the vector sum of forces acting on the system is zero. On the other hand, in the rotational equilibrium, the vector sum of torques, because rotation is related with the axis of the rotation and the torque is one of them. So these should be the vector sum of the torques should be zero acting on the system, and this is called the rotational equilibrium. Another point is about the frames of references. It is of two types. One is the inertial frame of reference and another is non-inertial frame of reference. The frame of reference in which Newton's laws of inertia holds good. It is called inertial frame of reference. If the frame of reference has an acceleration, it is called non-inertial frame of reference. The next point is all the fundamental laws which have been formulated with respect to inertial frame of reference. According to the Galilean invariance principle, the fundamental principle, the fundamental laws of physics are identical in all reference frames which move with the uniform velocity. Uniform velocity means there is no change in the acceleration, and that is with respect to one another. This is about the fundamental principle that goes with the Galilean invariance principle. This is the 30th point of friction. It is an opposing or retarding force which comes into play when a body tends to slide over the surface of another body. Another is the sliding friction. It is an opposing or retarding force which comes into play when a body tends to slide over the surface of another body. The next one is the limiting friction. It is the maximum value of static friction which is in play when a body tends to slide over the surface of another body. Dynamic or the kinetic friction. It is the opposing or retarding force which come into play when the body actually slides over the surface of another body. Next point is about the laws of friction. Among that, the first is the direction of the force of friction is opposite to the direction of the motion. The force of friction depends on the nature and the state of polish of two surfaces in contact. If they are polished, in that case the friction is less within the point of contact and the surface of the object. If there is roughness, then friction offered will be more. Now, continuing with the laws of friction, in that series, the third point is the force of friction acts tangentially to the interface between the two surfaces. The next is the limiting friction is directly proportional to the normal reaction between the two surfaces in contact, and the limiting friction is independent of the area and whatever may be the shape of the two surfaces in contact, provided the normal reaction has not changed. The 35th point is about the coefficient of friction. It is the ratio of limiting friction to the normal reaction denoted by mu. Angle of friction. Angle of friction is between the resultant of the normal reaction and the limiting friction and with the normal reaction. Here R is the normal reaction and F is the limiting force. So from figure we have tan theta is equal to limiting friction upon normal reaction, and this thing is equal to mu according to this relation. Now it is concluded that tan of the angle of friction is equal to the coefficient of the static friction. The next is the angle of repose or the sliding angle. It is the angle which the inclined plane makes with the horizontal when the body is placed on it just starts slipping. It is denoted by phi. So you can just see this is the body that is just going to start the slipping, and the weight mg is acting in the vertical downward direction. R is the normal reaction, and this angle phi is the angle of repose or sliding angle according to the definition, and the body is slipping in this direction and frictional force is in the upward direction. So this is resolved in two of the direction, this weight mg cos phi and mg sin phi. Now it is clear from the figure that tangent phi is equal to the limiting friction on the sliding plane by the normal reaction R, and that thing is equal to mu, the static friction. Here again we get the tangent of the angle of repose is equal to the coefficient of static friction. The next is the acceleration of a body sliding down on inclined plane. This inclined plane is there, and with what acceleration it is moving? This is given by A equal to G sin alpha minus mu cos alpha, where alpha is the angle which the inclined plane makes with the horizontal. The next point is about when a body moves through a distance s over the frictional horizontal plane. The work done is given by W is the work done. This is equal to mu. That is the coefficient of static friction mg into the distance. Otherwise, the formula of work done is force into distance. So this part is denoting the force here and it is multiplied by the distance. The next is about the work done in moving a body up an inclined plane through a distance s is given by mg into distance into sine theta plus mu cos theta. The next is about the rolling friction. It is opposing force which comes into plane when a body actually rolls or tends to roll over the surface of another body. The next is about the centripetal force. Centripetal force required by a particle of mass m moving with velocity v of a circle of radius r is given by F equal to mv square by r, or F is equal to mr omega square. V is equal to r omega. These relations, angular velocity, angular acceleration, we have already discussed in the unit number 2 kinematics. You can see the link below and can find out those terms that are related to the circular motion. Here I am taking the centripetal force. So the next is, this force is also equal to 4 pi square mr by t square, where t is the time period, or F can also be written as F is equal to 4 pi square mr nu square, where nu is the frequency. We have nu is equal to 1 upon t, this relation, so that thing is replaced here, and 1 upon t square is mentioned as nu square. Omega is the angular velocity that we have used in this relations, t is the time period, and nu is the frequency. The centripetal or the radial acceleration is given by v square by r. Now the 44th point, when a particle moves with uniform circular motion, it has only one acceleration called centripetal acceleration. But when a body moves with non-uniform motion, circular one, it has two accelerations, centripetal acceleration and the tangential acceleration. This acceleration, that is centripetal, it is directed towards the center of the circle. On the other hand, when the circular motion is non-uniform, the centripetal acceleration, that is directed towards the center of the circle, and tangential acceleration is directed along the tangent. The next point is, when while taking a turn, the cyclist should make an angle theta with the vertical such that tan theta is equal to v square by rg. V is the velocity, r is the radius of that arc that it is being making, and g is the acceleration due to gravity. When the outer edge of a circular track is raised above the inner edge, two edges are there, one is the inner side and one of them is the outer side. The outer side one is bit raised. The track is said to be banked. This type of track is called a banked track, and the angle of banking is given by the same formula that we have seen there, tan theta equal to v square upon rg. Next point is about the minimum velocity of projection at the lowest point of the vertical circle so that particle may loop the loop is given by under root 5 gr. G is the acceleration due to gravity and r is the radius of the circle. The next is the maximum speed with which a car can take a turn on a circular level road is given by mu s into r into g, where mu s is the coefficient of static friction, r is the radius of circular turn, and g is the acceleration due to gravity. The next point is about the maximum speed with which a car can take a frictionless banked circular track is given by under root gr tan theta. Here theta is the angle of banking. Next point is the maximum speed with which car can take a turn on a rough banked circular track is given by under root tan theta plus mu divided by 1 minus mu tan theta rg, where mu is the coefficient of the friction.